Alright, Year 11, welcome back to Methods. Hey, we are looking at exercise 5C today and looking at functions. Now, one of the first things that you need to know is actually to work out and determine whether something is a function or not. Yep. And so, here is how we can go about it. It says, a function is a relation such that for each x value there is only one corresponding y value. So, what you are looking at here, if you've got the x value, and let's say that's the first coordinate here, you've got a, these are the same, yep. If for that value, they have to have the same corresponding y value here, yep. So in this case, both this b value and the c value would have to be the same in order for this to be a function, yep. If you have some coordinates and the x value is the same, yet they have different y values, then it's not going to be a function. Yep. So in this particular case, worked example number 18, it's asking, hey, with these set of ordered pairs, which ones are functions? Okay, so you're looking to see that any of the coordinates that are here, if they have the same x coordinate, they need to have the same y coordinate. Yep, they can't have a different y coordinate. So here, you're looking at what's going on. There's a -3, -1, -6, and +1. They are all different. Yep. So in this particular case, there's none that are the same or have the same x coordinate. So we can't even really check. So in this particular case, it is a function. On the other hand, if we're looking here at this one's got the coordinate -4, and this one's also got the coordinate -4 for the x value. Now, as we said, for it to be a function, they cannot have different y values. Yep. So in this case, you can see here, this one's -4 and 1, and this one's -4 and -1. Yep. So it's got different y values for that same x coordinate. In this particular case, it cannot be a function because of that. Yep. Likewise, also the other thing is, you've got -6 as well, and also they've got different y coordinates as well. So as we said, it's not a function because there is an x value with two different y values. Cool. Now, this is so you can do it that way and look at it, or you can do what was almost my favorite activity in the whole of maths methods. It's using what's called the vertical line test. Oh, this is cool. It says, if a vertical line can be drawn anywhere on the graph and it only ever intersects the graph a maximum of once, then the relation is a function. Cool. So what you would do is you would get out I would get out my vertical line, and often it's the meter ruler in the classroom. I'm not in the classroom at the moment, so I don't have my big meter ruler to do the vertical line test. So I've just got a normal ruler. Yep. Now, you do need to know the difference between vertical and horizontal. Yep. This is the vertical line test. Vertical goes straight up and down. Yep. So we're going to go side to side. Yep. To check the vertical, apply the vertical line test. All right, let's actually use it. It says here, is the function, I'll put my vertical line down. It says, is y equals x squared a function? And then it's saying, hey, state the maximum domain and range for that particular function. Alrighty, so what we said before is you can use the vertical line test to check whether it is a function or not. So when you are using the vertical line test, you get it out. Actually, that's not going to work here. I'll have to use another vertical line. Just bear with me, getting my vertical line happening. Let's make it vertical. Yep. Okay, so what we're going to do is I'm going to use my vertical line, and I'm going to move it left to right. And if this is a function, it's only going to cut the vertical line once at any particular point. Alright, so as I'm going along here, notice I'm moving it left to right. It's only going through the vertical line once at any particular point. Once, cutting. Cool. It's a function because it only cut the line once. Tick. Yep. It wasn't more than one spot passing through the vertical line as we went through. Yep. Also, what you can see is if we talk about the domain, the domain for this one obviously goes on forever this way. So it goes to negative infinity, and it also goes to positive infinity. Now, rather than writing, okay, it goes from negative infinity to positive infinity, you can just say the domain is all real numbers. Yep, so R. Cool. They're also asking, hey, what is the range? So in this particular case, you can see, in terms of its y values, the graph doesn't go below 0. And it goes up to infinity. So what we can say there is the range is all positive real values, including, and 0. Yep, so 0 is included in that particular one. Cool, so we've said the domain and the range. Cool. Next one says, is x squared plus y squared equals 4 a function? State the maximum range and domain for that. Cool. So, first of all, we need to work out whether it's a function. So, again, you would get your vertical line. Yep. Okay, I'll have to use my virtual one here. So I'm going to go from left to right, and we're going to see if it is a function. All right. Some of you might already have an idea of what's going to happen here. But let's actually do it. So I'm going to run the line across, doing the vertical line test now. I'm doing the test. We're going to see if it, make sure, because for it to be a function, it's only going to cut once. All right. So I'm going to do the test as we're going through. Straight away, you can see here, it's cut on more than one location on my vertical line. Yep. You can see it's cut here and here. Even as we move across, it's cutting up the top here. It's cutting in more than one location as I'm doing the vertical line test. Yep. In this particular case, after you've done the test with the vertical line, you can see because it cuts more than one location, this is not a function. Yep, not a function. Cool. How cool is that vertical line? Really easy to test to see whether it's a function or not. Just run it across. If it cuts once at any point, it's a function. If it cuts more than once, it is not a function. So straight up, this is not a function. From there, you can also be asked to see what the domain and the range is. Like we were doing the other lesson, domain, you can see it goes from -2 to +2, and that's from the circle. That's the radius squared. Yep, remember from the other day. So the radius is 2 in this particular case. If the center is at 0, 0, 2 that way is obviously -2, and 2 that way is +2. Same obviously this way. So the domain is going from -2 through to +2, and likewise the range is going from, imagine that's a straight line, is going from -2 up to +2 as well. Alrighty, good. This is pretty fun. There's a bit of theory that we do need to have the chat about. Yep. Alrighty, you will probably have to look over this again just so they're happy, because there's a bit of notation that you need to understand. So we're talking about function notation. It says functions are usually denoted with lowercase letters such as f, g, and h. Perfect. If f is a function, then for each x in the domain of f, there is a unique element y in the range such that x, y has elements of f. Cool. So the element y is called the image of x under f. Cool. Or the value of f at x. And the element x is called a pre-image of y. Cool. Some pretty heavy terminology there. What you need to know is primarily that since we get a y value from the function of the x value, what we do is we use the notation which is called f of x. Yep, and that is read as I've said. It's f of x. So the function is f, and we're after x. So it's f of x. So rather than writing in the old days when we were in year 10 and start of year 11, we used to write like an equation, y equals 2x plus 1. What you can do is you can write it as a function of x. Yep. So you can write f of x is equal to 2x plus 1. Okay, so the same thing. It's just writing it using function notation. Yep. And the advantage of doing this is that if I said to you, okay, I want to find out what happens when you make x equal to 2 for this equation, what you can do is you can just say find f of 2. Yep. So find the y value when x is equal to 2 by writing this. Yeah. Maybe we've even seen some of this stuff. Yeah, I think we've seen some of this stuff before in methods. Yep. So if you say you define the function f of x, then you can just go, hey, substitute in 2 by doing f of 2, yep. Or if you did f of -4, it just means substituting in -4 as x into the equation, as you can see from this. That's meant to be an arrow down. Cool. That looks like a happy face. All right. Now, it says here, by incorporating this notation, we have alternate ways of writing functions. All right, so traditionally, obviously, we used to write things like this: y equals x squared, to work out the points x and y. And it has the domain, obviously, all real values for that. Another way you can write it is using this notation here. Yep. In using that notation, you've got the function, you've got what its domain is. This here is the domain. And after this little arrow, it's what's known as the range or the codomain. It's that one there. Yep. And then obviously we write it of f of x because it's the function we're using f. They said earlier sometimes they use other letters, like they can use g and h. Generally they use f for function. And obviously we've written out the function f of x, and it's equal to x squared in this particular case. So it's just slightly changing things around a little bit. Likewise here, if you had an equation, y equals 2x take away 1, and you had it for x elements between 0 and 4, writing it using this other notation, you could have f, you could say the domain is between 0 and 4, and its codomain is all real numbers for the function, and so forth. Likewise, this one here, y equals 1 over x, and it's got a domain of all real values except for 0, where the asymptote is for this one. In this particular case, rewriting it out using this other notation, f is going to be, here you write the domain, all real values except at 0, its codomain's real values, which is the range here, and writing out the function here. Some other times you'll see, rather than the mathematicians writing out fully the range and domain, they'll just write dom f, which is just short for domain of f, and also the range, they'll just write ran f, which is just short for the range of f. Yep. Cool. So example number 10 is just asking you to do the same sort of thing as I just spoke about, and change it to this particular type of notation. Hopefully you can have a read through that and understand it based on the information above. Worked example number 11 is actually now using this function notation, f of x, and it's pretty cool. Once you've got f of x and they've got a function 2x squared plus x, it's asking you to find each of these. So again, if you had to find f of 3, it means substituting x being equal to 3 into this equation. Yep. So wherever you see the x, you're going to plug in 3, which we can do, and we can evaluate it. Likewise, this one, plugging in -2 into the equation, we're evaluating it. Happy days, wherever you see the x, we're going to substitute in x take away 1. Yep. Simplifying things down, check. This one, we've got f of 1 over a, plug that in wherever you see the x in the equation, simplify things down. Cool. This one here, oh, I like it. It says consider the function defined by f of x equals 2x take away 4. Now, it says find the value of f of 2 and f of t. Cool, so like we did before in the previous exercise, example, where you see the x, we're going to plug in 2. So what they've done there, plugged in 2, 2 times 2, take away 4, it's 0, check. And also wanting you to do f of t. So where you see x, you're going to plug in a t. That's easy enough to do, just stays like that. B, it says find the values of x for which f of x equals 6. Okay, so in this case, it's not plugging in 6 into the equation, it's saying the function is equal to 6. So you would write out the equation, or the function in this case, 2x take away 4, and they're saying that function, f of x, which we just wrote down here, is equal to 6. Hopefully from here you can use your basic math skills to rearrange and solve that. Yep. Let me get rid of this, I'm getting a bit carried away with my texter. Alright, this one here, it says for which values of x does the f of x equal 0, same difference like we did before. Write out the function, make it equal to 0, and solve. Yep. For what values of t is f of t equal to t? Okay, so this again, it's not f of x, it's f of t. So you're going to be substituting t into the function, which we can do. So it'll be 2t take away 4. And they're saying it is equal to t. So you'd write out the function, f of t. It's equal to t. You can rearrange things. Hopefully you know how you can move 4 over this side, move the t over this side, and find out what's going on there. T is equal to 4 in this case. It says for which values of x is f of x greater than or equal to x? Yep. So again, just because it's an inequality, no need to jump up and down and panic. We can deal with it. Yep. So here you'd write out f of x, which is 2x take away 4. It's greater than or equal to x. Yep. And you can solve this inequality. We did this in year 10. Likewise, it says for what values of x is f of x less than or equal to 3x? Write it out, f of x, put in the inequality sign, put in 3x, and we can do the calculations here. Yep. Just remember when you're dividing, just remember how inequalities work. Yep. Generally speaking as well, we prefer it written with the x's being greater than or less than or equal to first rather than this way around. So all they've done is they've moved that way, the x over to this side and negative 4 over there. But remember, when you do that, you need to make sure the inequality sign is facing the correct direction. Alrighty, what's this here? Oh, cool, you can play around with your calculator and do these types of things also. So I'd encourage you to have a bit of a look at that. Yep. Okay. Really quickly as well, there is a restriction of a function. Yep. You can actually say whereabouts in the domain you want the graphs or the functions to exist. So, for example, here you've got the function f of x equals x squared. There's no restriction. Yep. It's going to be for all real values in the domain. But they're saying here it's the same function except they're calling it g of x this time just to distinguish the fact that it's got a restriction on it. So in this case, they're saying, hey, we're only going to sketch it between -1 and +1. Yep. So x is going to be greater than or equal to -1, but x is going to be less than or equal to 1. So you pop those on there and you can see it's only sketched in between those, in between there for its domain. Yep. Likewise over here, this one they're saying, hey, for h of x is equal to x squared, they're saying we only want to sketch it for all real positive values, including 0. Yep. So remember unions and 0. That's why it's got the dot there. Yep. It's including 0. So in this case, again, it's sketched there. Obviously, it's being sketched from 0 and all real values means it goes on to infinity that way. Yep. Cool. I reckon you guys can have a look through that and be happy. And you can also get your calculator to draw graphs restricted to a certain domain. Now the trick here with these ones is when you put it into your calculator, you're going to put in a little bar after the equation. So a little bar you'll find is like a little line that goes straight up or down. So you type in the equation and you use the bar, goes up and down, and then after the bar you put the domain for where you want the graph to be sketched. Yep. So for this one, if you wanted x squared plus x, and then you only wanted it to be sketched between -1 and 1, obviously put the bar, put that in there, you can see it'll sketch it just between that domain, which is very helpful. Cool. Fair amount of information from me today. Hopefully this gives you plenty to have fun with in maths. It's maths, it's fun anyway. Alright, bye for now.